For problem number 4, it says find all values of x for which the function is differentiable. What does that mean? It means find all the x values where the derivative exists. So first step is to find the derivative. And I have, I suppose I have chain rule, because there's function on the outside and then function on the inside. But then it's a quotient rule on the inside. So the first thing I'll do is I'll take the derivative, because I want to see where the derivative exists. That's where it's differentiable. So, oh yeah, the derivative of the square root, that would be like 1 over 2 times the square root. Derivative of the outside with the inside the same. That's what I'm doing right now. And then I get 1 plus x squared. Derivative of the outside with the inside the same times the derivative of the inside, and that's quotient rule. So I'll say low 1 plus x squared. Have to put it in parentheses because it's a binomial. Low d high, derivative of the top is negative 1, minus low d high minus high d low, parentheses, high d low, all over low squared, 1 plus x squared, all of that squared. Low d high minus high d low all over low squared. Okay, so I really don't even need to, wait, is that all I have to do? Derivative of the outside with the inside, same times the derivative of the inside. Okay. I don't even have to simplify it anymore. I just need to know where this is defined. I need to know for what values, like, does it exist? So I'm thinking, all right, I need no zeros in the denominator. I need 0 or positive in the in a square root, and I need only positives in the natural log. But I don't even have any natural logs in this problem right here. So first I'll look at the denominators. This cannot be 0. However, it won't be 0 because x squared, no matter what I plug in, it's going to become positive, and 1 plus a positive number will never be 0. So I don't have to worry about that. So that's done. I don't care. Now I just need this to not be 0 and also to not be negative. But again, 1 plus any positive number is not going to be negative. So really, I need this to not be 0, because if the top was 0, then this entire fraction right here would be 0, and then I'd have a 0 in the denominator of this fraction. So that doesn't, I can't have this being 0, and I can't have this being negative. Remember, this is always positive, so really I just can't have this being negative. So what does that mean? What can it be? Well, it can't be 0, so it has to be not 0, and then it can't be negative, so 1 minus x must be greater than 0, right? And then if I add x over, I get 1 greater than x, or x less than 1. And that's it. If x is less than 1, then we don't have a problem here. We're never going to have a problem there. And we're good to go. We're good to go. Yes, that's where it's differentiable.